What is your favorite season? What is it? What's your favorite time of the year? We are super lucky. We live in Michigan, and that means that we get to experience all 4 seasons. We get snow in the winter, we get rain and flowers in the spring. We get a nice hot, dry summer with lots of sunshine. We get a nice, cool, crisp fall with the autumn colors. What's your favorite season? Okay, my favorite season is fall, and it's because I like the temperatures. It's nice outside and it's good sleeping weather. So we've been talking about the seasons, and we've been talking about Earth's place in space. And today our learning target has to do with the last couple of lessons. We're going to look at I am able to describe how Earth moves in space to explain the length of a year. How old are you? I'm super old. Not going to tell you how old. I'm super old. Our key term is revolve or revolution. Say it with me. Revolve or revolution. And it means to move in a circular orbit. Today, you're going to draw a diagram of the Earth revolving around the sun. And then you're going to label where the Earth is on your birthday. Also include revolve and rotate, Earth and sun. You can use revolve or revolution, or rotate or rotation. And then when you figure out how old you are, you know that it takes 1 year to go all the way around the sun. How many revolutions have you made around the sun? So this would be your current age. You don't have to be exact. You can just round it to the nearest year or year and a half. So if I was going to do that, I might look at this and say, okay, Mrs. Tomlinson's birthday is in September. And so this is fall, and I look at the arrows of the revolution around the sun. So this is March, right? This is the first equinox, right? 12 hours of sun, 12 hours of day, 12 hours of night. This is the second equinox is in the fall, 12 hours of day, 12 hours of night. This is the winter solstice, where we are kind of right now, December 21st, where you have very short amount of daylight and a longer nighttime. Like at 6 p.m. it kind of feels like midnight because it's pitch black out. And June 21st is the summer solstice. This is the longest amount of daylight. What I want you guys to notice here, also while we're here, is that the Earth's axis never changes. The tilt of the Earth stays the same all the way around the sun. Every point in its revolution, the tilt is the same. My birthday's in September, so let's see if we go through the months. We could start at December, right? So winter solstice, December. And then we have January, February, and then March. So maybe January and then February, March 21st, right? April, May, June, July, August, September, October, November, and then we're back at December. So Mrs. Tomlinson has made quite a few revolutions around the sun. You're going to record how many revolutions you've made around the sun right here today. Notice this is page notebook 47. We'll also be doing notebook page 48. I know you're excited about lots of notebook today. So for notebook page 48, we're going to look into lunar eclipses because there is a relationship between the sun and the earth and the moon. So our learning target for learning page 48 is I can use a model to explain a lunar eclipse. And the definition of lunar eclipse is here, but here's the term, lunar eclipse. Say it with me, lunar eclipse. It's a darkening of the moon as it passes through Earth's shadow. Today you're going to draw a diagram of a lunar eclipse and label the sun, the earth, and the moon, and include the umbra. When you're done, it will look something like this. I know that's just a picture. I didn't really draw it. I want you to draw it so that you can remember it. What happens during a lunar eclipse is the sun is always shining on the earth, and the earth is always turning, and the moon is always orbiting around the earth. But at one point, the moon actually gets on the opposite side of the earth from the sun, and the earth's shadow falls on the moon. And then you get something called a lunar eclipse. And the umbra is what we call the shadow, okay, the full shadow. There are 4 to 7 lunar eclipses that can happen per year. That's kind of exciting. And during a lunar eclipse, the moon is in full moon phase. And we're going to look at the moon phases later today. Oh, not today, next lesson. Oh my gosh, Mrs. Tomlinson, another notebook. Yes, another notebook page. This one is to look at a solar eclipse. So I can use a model to recognize a solar eclipse. Our term, solar eclipse. Say it with me. Solar eclipse. It's when the moon passes between the earth and sun, causing a shadow to fall on the earth. Now, Michigan, you could actually see a couple of years ago, we actually had a solar eclipse. Did anybody see it? Raise your hand if you saw it. Tell me a little bit about it. You know, if you knew about it, that never look directly at the sun during a solar eclipse, because the harmful rays of the sun can still damage your eyes. Even though it looks like there's a shadow and the sky turns a weird color and it's kind of creepy and cool, the UV rays are still coming from the sun and you can still really damage your eyes. So even if there's not a solar eclipse, don't look at the sun. Those UV rays are damaging. Today, on notebook page 49, you're going to draw a diagram of a solar eclipse. You're going to label the sun, earth, moon, and include the umbra. It will look something like this, okay? So here's what happens during a solar eclipse. The earth is always going around the sun, and the moon is always going around the earth, right? But at some point, the moon gets in between the earth and the sun, and it casts a shadow on the earth. So only these people right here can experience a full solar eclipse. Everybody else can see maybe a partial solar eclipse when they're looking up at the sky with their special devices to protect their eyeballs. But that is what happens is the moon gets in between the earth and the sun, and a shadow gets cast on the earth. Pretty cool, huh? All right, you're going to watch some videos, you're going to see some sights, and then you'll be putting together diagrams of where your birthday is, what it looks like when there's a lunar eclipse, and what it looks like when there's a solar eclipse. All right. Really have fun drawing today. Use whatever you want, circular things to trace in case you want to do circles that are perfect. Don't worry about perfect circles, though. Just make sure you have your labels. All right. Today, don't look at the sun, but definitely look out the window, see what you can see, experience some science in the night sky or in the day sky. Anyway, I wish you another great revolution around the sun. Happy birthday!